Okay, this section is just over applications of quadratic equations. So how can we use quadratics to solve real-world problems? So here we go. The objective is just to use quadratic equations to solve real-world problems. And we got this chart here. One of the coolest things I think about Algebra 2 is the direct correlation between quadratics and things being dropped and or projected in the air. Okay? So if something is dropped, the placement of that object, so if I take my pen here and I drop it, the placement of this, meaning the height of my pen over time, okay, with respect to time, can be modeled by using a quadratic. So if I drop this pen, over a certain time, the height changes. Would you guys agree with me there? So after 1 second, it changes. After a half of a second, the height changes, okay? And that height can be modeled by using quadratic equations. So if something is being dropped, then the height of that particular object is going to be negative 16 t squared plus h naught. Is anyone taking physics here or are taking physics? Okay, I'm sure you guys talk about this in class, so I might teach it a little bit different. Basically, h naught, and it's just an h with a little zero, a little subscript 0, that's just pronounced h naught. H naught is our initial height. So how high are we dropping it from? Because would you guys agree with me that the height of a certain object after a certain time all depends how high it starts? Would you guys agree? It's going to take something a lot longer to hit the ground from 50 feet as it would 10 feet. Okay? Now, if something is being thrown or launched into the air, now we have to add a certain component to that, because no longer is it just being dropped and gravity is just acting on it. Well, now we have that force being thrown into the air. Or really, it could be thrown downward. Would you guys agree with me there? That if I go up on the school, okay, and I take a math textbook, I could throw that thing in the air, or I could actually throw it downward, okay? Both of which will alter the time it takes for the book to hit the ground. So if something is being projected, well then our height with respect to time is going to be negative 16 t squared plus v naught t plus h naught. That looks a lot worse than it is. V naught, that is our initial velocity. What's velocity? Speed. Velocity is speed, okay, with direction. How fast are we throwing that in the air when it leaves our hand? Or how fast are we throwing it maybe downward as it leaves our hand? And then h naught, again, is our initial height. Okay, now where does this negative 16 come from? Well, first of all, it's negative because with gravity, it's going to be forcing it down. The shape is going to look like be a parabola, but it's going to be upside down. And where do we get 16 from? Well, that comes from calculus. So if you want to know where that comes from, take calculus. But basically, that's the force of gravity acting upon whatever object. Okay? Yannick?
What does velocity mean?
Velocity is speed.
Okay.
You okay with that?
Yeah.
Velocity is speed. So here we go. It says, for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. Okay? Write a function that gives the height h in feet of the container after t seconds. Now, are we throwing the box, or the container, excuse me, or dropping? We're just dropping it, right? So therefore, that would be our first equation. So it's going to be h of t. The height after a certain time is going to give me, or going to be negative 16t squared. And our initial height here is 50 feet. That's it. We wrote the equation. We used our information given to write a model of this situation. Okay? The next part says find the height of the container 1.5 seconds after it's dropped. So what this function gives us is the height after a certain time. So if I want to know the height after a certain number of seconds, plug in that value of time. So we want to know what is the height after 1.5 seconds. So we're going to do h of 1.5. So negative 16 times 1.5 squared plus 50. So again, order of operations, 1.5 squared. Help me out here. That's 2.25. Now take 2.25 times negative 16. And then add 50 to that. 14? 14? 14. H of 1.5 equals 14. What does this mean?
How the height of it was at 1.5 seconds.
Great. After 1.5 seconds, we dropped it 1/1000 and a half. This container is going to be 14 feet off the air. Or off the ground, I should say. Again, 1.5 squared, you get 2.25. Times negative 16, hit enter, and then add 50. I think you should get 14 there. Any questions there? You agree with me, James?
Yeah.
Perfect. Now the next part says, how long does it take the container to hit the ground? So we want to know, it took 1.5 seconds to get from 50 feet to 14 feet, but we want to know how many seconds does it take to hit the ground? Now, when something hits the ground, what's the height of it? It's 0, isn't it? So here's what we're going to do. We're going to take our equation or our model that we came up with, and I'm going to plug in 0 for h of t, because h of t represents the height after a certain time. Well, we want to figure out what's the time it takes to hit the ground. So 0 equals negative 16t squared plus 50. Now, from here, we're going to use one of our solving methods. Can we square root it? Can we factor it? If we can't do one of those, well, then we'd have to complete the square, do the quadratic formula. How do you think we should solve this one? Reed, what do you think? So you minus 50, so you want to move to the other side. Which method are you using? Do you know? Yeah, what method was Reed using there? I think he was using square roots, right? Guys, so if we're just given a t squared and no t, well, I can minus 50 on both sides. I'll get negative 50 equals negative 16t squared. Now I can divide both sides by negative 16. Now I'll work up here, so I'll get t squared equals, what's negative 50 divided by negative 16? 3.125. Now to solve for t there, I'm going to square root both sides. So t is going to equal the square root of 1.25. What is that? And I'll just say this, guys. These are real life situations where we actually need an answer. It doesn't really help us so much to leave it in square roots anymore. It does if it's just a math problem, but now we're tying it to a real world problem. Let's actually get the number there. So what's the square root of 3.125, Rachel? 1.767. And does that keep going?
Yeah.
What's after the 7?
76695.
After this 7, there's another 7?
Yeah.
So let's call this 8 then. Let's round it up. Guys, I'm a big believer in rounding at least to the hundredths. If you want to round to the thousandths, which is 3 decimals, that's fine. At least the hundredths, so at least 2 decimals. Now, did we put this square root symbol in ourselves?
Yeah.
We did. So really, I need to have plus or minus here. Now, what does that mean? Well, that means here's my graph. I'm up here at 50 feet, aren't I? And after a certain amount of time, it hits the ground. Well, it's a parabola, so the parabola needs to be over on this side as well. Now, does that side resemble real world in this situation? No. So we're really exempting or excusing that part of the problem, and so I'm not worried about the negative part because it doesn't apply to this situation. So the answer would be after 1.768 seconds, that's when it's going to hit the ground. Questions there at all? Okay. Example 2 says find the value of x if the area of the triangle is 40 square units. So here I have a triangle. The area is 40 square units. What's the formula for the area of a triangle? Great. 1/2 the base times the height. So I'm going to have 1/2 times my base, which is x plus 4, times the height, which is x, and that's going to equal my area, which is 40. Now, we've done problems similar to this where we had rectangles and maybe parallelograms, but nothing a triangle before. So what I'm going to do is I'm going to multiply all 3 of these together. I'm going to start by distributing this x. So I'm going to have 40 equals 1/2 x squared plus 4x and then I need to distribute this 1/2. So I'm going to have 40 equals 1/2 x squared plus 2x. Now what should we do? Whenever we have quadratics, we want it equal to what? 0. So what's minus 40 on both sides? So then I'm going to get 0 equals 1/2 x squared plus 2x minus 40. Now, this 1/2 kind of bothers me a little bit. It's hard to factor when we've got 1/2. It's kind of weird. We could maybe complete this, do the quadratic formula, but we've done this before where, like in the bell ringer today, I've divided everything by 2. You can do that as long as you do everything by 2. So if I wanted to multiply everything by 2 just to get my a value to be 1, I can absolutely do that. So what I want to do now is I'm going to multiply everything in this equation by 2 so my a value gets to be 1. So now I'm going to have x squared plus 4x minus 80, and that's going to be 0, or equal to 0 now. I just moved the 0 to the other side. Now, how are we going to solve this? Niall, what do you want to take to the problem? Factoring. Can we factor this, class? Try it. Go. See if we can factor it. Go. So we want to try to factor. Does this factor? Anyone find any numbers that work? Factors of negative 80 that add up to 4. I can't think of it at the top of my head. And again, we want to factor it first. So if we can't factor, now we either need to complete the square or do the quadratic formula. Which one do you guys want to do here? Could do quadratic formula. Now here's the question. Completing the square only works certain times. Quadratic formula you can do whenever you want. Is this the one where we could complete the square? It is, because my a value is 1 and my b value is positive. So let's complete the square here. Again, if you're a quadratic formula person, you could do that here. But since we can actually do the completing the square, let's do it. I'm going to move 80 to the other side. I'm going to get x squared plus 4x, and that's going to equal 80. Now I need a new c value. Take half of my b value, which is 2, square it, which is 4, add it to both sides. Now I can mini-marf. I can rewrite this as x something, x plus what? 2. X plus 2 equals 84. Now I'm going to square root both sides. X plus 2 equals plus or minus the square root of 84. I'm going to minus 2 on both sides. And x is going to equal negative 2 plus or minus the square root of 84. Now here's what I'll say to you guys. Can I simplify 84? I can. I can take out a 4, but here's the problem. Not the problem, but in the end, it's a real world problem. I want a decimal. I don't want negative 2 plus or minus square root of this. That's not useful for us when it's applied to real world. If it's just a math problem, we want to keep it like that. If it's real world, no. So what I'm going to do is I'm not going to simplify it. I'm not going to waste my time. I'm just going to plug it into my calculator. Now, watch this. I know if I take negative 2 minus any number, what kind of number am I going to get? Negative. Can I have a negative value for x here? No. So I'm not going to worry about that either. So I'm just going to take negative 2 plus the square root of 84, and that'll be my answer. Negative 2 plus the square root of 84. Like 7 point something? 7.1. So I'll do 1.7. You say 1.65? I'll round to 7.17. Now again, we want to check our answer? Absolutely, let's do it. This is 7.17. This is 11.17. Take 7.17 times 11.17 times 0.5, and hopefully we get something very close to 40. Do it. Times 0.5, because it's half. Our formula is half times our base times our height. 40.04, so it's really close, but again, that's because we rounded. Questions there at all? Okay, top of the next page. Now we're going to be talking about a projectile that's launched into the air. Okay, so if something is thrown into the air and actually thrown downward, we can model it like we talked about at the beginning of class. So here it is, an athlete on a track team throws a shot put with an initial vertical velocity of 24.6 feet per second. The shot put has a height of 6.5 feet when it leaves the thrower's hand. So here's what this tells me. This is my initial velocity, 24.6 feet per second. Okay, and then this is my initial height, because when it leaves the thrower's hand, that must be 6.5 feet off the ground. Which that makes sense. People are usually in between 5 and 6 feet. That makes sense. Now, one thing we want to pay attention to, are we throwing this up or throwing this down? Because that would matter. Because if the person would throw this down into the ground, it would have to be negative 24.6. We would probably assume this we're throwing it up since we're throwing a shot put. Otherwise, that would be a really crappy throw, huh? Good. So it says write an equation that models the height h of the shot put after t seconds. So we're going to use our model on the front page. We're going to go h of t. Our height after a certain time is going to be negative 16 t squared plus our initial velocity, which is 24.6 t times time, plus our initial height, which is 6.5. So there's our model. Questions about how we got that? Now the next part says, how high does the shot put travel? So we want to know the maximum height, which means we have to find the maximum. If we would model the height over time, would you guys agree that it's going to leave the hand at 6.5? It's going to go up and come back down. So we want to find the maximum height. How do I do that? We haven't forgot already, have we? We're going to find the vertex. How do we find the vertex? How do we find it, though?
Opposite of B over 2.
Thank you. X equals opposite of B over 2A. Opposite of my B value is going to be negative 24.6 divided by 2 times my A value, which is negative 16. So I'm going to get negative 24.6 divided by negative 32. What do I get when I do that? Everyone should be doing that. I don't think my calculator's been working. Can I do it? Negative 24. Nope. I don't think it's... What's that, Rachel?
I think it's 0.768. 6875. 875. No, it's
Positive.
Should be positive because I have a negative divided by a negative. If you got a negative in your calculator, it means we might have typed something in wrong. Okay, so what should we call this? I don't want to use that whole number. Can we call it, let's just call it 0.77. So what does this mean? What is this number? Tyler said it's the axis of symmetry, right? Isn't our axis of symmetry where my vertex occurs? Right? So with respect to this picture, our axis of symmetry is the x value of the vertex, which that's always the case. Well, isn't that the time that it takes? So what that means is after 0.7 seconds, that's when it hits the max height. Okay? Now, we need to plug that value in to the function to see how actually high the thrower threw it. So I'm going to do h of 0.77. So negative 16t squared, and actually t is 0.77, squared plus 24.6 times 0.77 plus 6.5. Okay, so we go over here, take 0.77 squared in our calculator. Everyone follow along with me because I feel like this is where people get lost or we get the wrong answer, we just type something in wrong. So 0.77 squared and hit enter. Then take that number times negative 16 and tell me what you guys get there.
Again,
Negative what?
9.4864.
Negative 9.4864. Is that right? Okay. Now we're going to come over here and take 24.6 times 77. 0.77. Marcus, what did you get there?
I got 15.9556.
15.9.
Oh, but I probably got that wrong.
No, you didn't.
I didn't?
No.
Lit.
9 what?
I think I did.
You didn't get it.
I got 18.9.
18.942 plus 6.5. So what I did there, when we have a number that's kind of not so fun to work with, take them each separately, and then lastly I can add all those together.
Is it 942 or is it 742?
9742?
No, I don't know if it's 942 or 742.
Oh, 942. When I add all those together, what do we get there?
15.955.
I don't like that.
That's the one I got.
That's right.
So you guys got? Oh yeah, I like that. No, I'm sorry. Rachel, say it again.
15.9556.
So roughly around 16 feet is how high, the maximum height of the shot put. And again, we haven't done anything out of the ordinary. All we've done is found the vertex. We've been doing that for a month and a half now. And then lastly, it says how many seconds, typo here, how many seconds, oh no it's not, how many seconds is the shot put in the air? Well, when it asks how many seconds is it in the air, basically I want to say how many seconds does it take for the shot put to hit the ground? So what's the height of the shot put when it hits the ground? 0. So negative 16t squared, I should say 0 equals, because we're plugging in 0 for t. 0 for h of t. Plus 24.6t plus 6.5. Now, I could factor that. We want to factor that? Probably not. Here we go. Quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So we're just going to plug things in. Opposite of b is going to be negative 24.6 plus or minus the square root, help me out here, b squared. That's a big one. Give me like 600 something. Grace, what do you get? 605.16 minus 4 times my a value, which is negative 16, times my c value, which is 6.5. All divided by 2 times my a value, which is negative 32. Now, I have two negative signs, which that means I'm going to get a positive plus there. So negative 4 and negative 16 is negative 30, or excuse me, negative 64, is that right? Positive 64?
Yeah.
Plus 6.5? Or I'm sorry, times 6.5? What do I get when I multiply those together?
416.
So negative 24.6 plus or minus square root of 605.16 plus, what did you say, Hannah?
416.
Even?
Yeah.
416, all divided by negative 32. Okay, I can multiply those two together, so negative 24.6 plus or minus square root of, that's 1021.16, all divided by negative 32. Okay, now let's understand something. I can't have a negative answer because that doesn't make sense. A negative seconds for the shot put to hit the ground. That doesn't make sense. So I'm going to have a number divided by a negative, right? So if I'm going to have a number divided by a negative and get a positive answer, I want my numerator to be what? I want it to be negative, don't I? I want a negative divided by a negative so I get a positive answer. Now, square root of 1,000, just type that in, square root of 1,000. What do we get there?
31.6227766.
Square root of 1,000. Just 1,000 even, just so I get you in the mindset of what this number is.
31.
Oh, 31, that's what you said. I'm sorry, I thought you was that. So 31. So we're going to have negative, okay? And if I take negative 24.6 plus 31 something, that'll give me a positive, won't it? So do I want to add it?
Yeah.
No, because if I take a negative 24.6 plus this number, that will give me a positive number, divided by a negative, in the end will get me a negative. See what I'm doing? I'm just thinking about the signs and which one I want to do. Now, could we just do both of them and then figure out, oh, this one's negative? You could, but I'm just thinking ahead a little bit. We don't want the negative one. So what I'm getting at here is the only one I want is the negative one. So negative 24.6 minus the square root of 1021.16 and hit enter and divided by negative 32. Everyone should be doing this because everyone needs practice of typing this into the calculator. What do we get for an answer? Liam, what'd you get?
1.76736.
I'll stop there, 1.76. Guys, what you need to do is stop and ask yourself, does that make sense? Does that even make sense? Raise your hand if you got that answer. Does that even make sense, though? Explain it. Why does that make sense, Cole?
It's positive, so it means it's like going somewhere else.
What's going? What is this answer? It's positive. I agree. It's going somewhere. What is this answer? What's the units? What's the label? Seconds. It takes 1.7 seconds for a shot put to go in the air. How many seconds did it take to get to its highest point? 0.77. So it's going to take a little bit more than that to come back down. I think that makes sense. I'm just letting you know, if you got an answer that's at 15.5, that's not realistic. A shot put thrown in the air isn't going to be in the air for 15 seconds. You know, I'm just kind of getting you guys to think, hey, does my answer make sense? If it doesn't, well then maybe I should go back and find my mistake or start the problem over or something of that nature. Okay, here we go. Last one. It says a rectangular reflecting pool in a park is 20 feet wide by 30 feet long. Guys, I don't know what in the world a reflecting pool is. Okay? But I know it's a rectangular pool of some kind. I'm going to draw that. The dimensions are 20 by 30. The park gardener wants to plant a strip of grass of uniform width. What's uniform width? Equal width, all the way around it. Okay, so this gardener is going to plant a strip of uniform width of grass all the way around this thing. That doesn't look very uniform. Okay? It says that she has enough grass seed to cover 336 square feet. How wide will the strip of grass be? Now, we don't know how wide this strip of grass is, so we're going to call that x. That little bit is x. That little bit is x. That is x. That is x. The strip is uniform. It's the same distance. We're calling that x. Okay? Now, do we know the area of the pool?
Yeah.
Yes.
What's that?
30 times 20.
It's just 30 times 20, right, Marcus? 30 times 20 is
600.
I think that's 600. So the pool has an area of 600. We know the biggest that this strip of uniform grass could be is what? 330. It can't be any bigger than that. Okay? Because we don't have any more grass seed. So the green is 336. So what's the area of the whole entire thing?
936.
It would be 936. See what? Follow me there? I know the area of the pool, 600. I know the area of the grass, 336. Well, the area of the whole thing would be 936. Okay? So I know the area of the whole entire thing is going to be equal to 936. Now, I know the area of the whole thing. What is our dimension of this, of the horizontal, our horizontal dimension? Well, I've got an x here, right? And I have an x there, right? And I have 30. So it's like x plus 30 plus x. What's x plus x? Careful. Plus.
2x.
It's 2x. So this dimension is 2x plus 30. What's our vertical dimension here? 2x plus 20. So if I want to find the volume of the whole thing, I would take 2x plus 30 times 2x plus 20. So what we're going to do is we're going to FOIL all this together. We're going to move 936 over, and then we're going to try to factor quadratic formula from there. So 2x times 2x is 4x squared. 2x times 20 is going to give me 40x. 3x times 30 times 2x is plus 60x. And then 30 plus 20 is going to give me 600 equals 936. So I get 4x squared plus 100x plus 600 equals 936. I need it equal to 0, don't I? Minusing 936 on both sides. So I get 4x squared plus 100x. Oh, this is going to give me negative 336, is that right?
Yep.
Equals 0. Now, we could jump into the quadratic formula right now, but again, we want to try to factor if we can. Is there a 4? Can I take a 4 out? I don't know. Is 336 divisible by 4?
Yes. Yeah.
It is. Sweet. So if I take a 4 out of everything, I'm going to be left with x squared plus 25x minus 84. Okay, that worked out nice. Now I'm trying to find factors of 84, negative 84, that add up to 25. So I'm going to have 1 and 84, 2 and 42, 3 and... Does 3 work at all? 3 and 28? Sweet. 4 and 21. 5 and nothing. What about 6?
14.
6 and 14. Oh, do those add up to 25?
What about 3 and 28?
Oh, so which one? Oh, which one works? Let's take a look at our signs here, because I know it needs to be negative. Multiply to get a negative. So that means one has to be positive and one has to be negative. This number is positive, so it has to be those. So I can mini-marf, okay, so I don't need to do all this extra work. I'm going to split it up right now. I'm going to have a 4 out there. I'm going to get x plus 28 and x minus 3. So set each of these equal to 0. I'm going to get x equals negative 28 and x equals positive 3. Wait a minute, I'm confused. What did I just find? The x's. I found how wide the strip of grass was. Can it be a negative? The strip of grass is 3 feet wide.